I can use models to show and explain equivalent fractions. So we're going to look at fractions and look at fractions that are equivalent. Models that we'll be using include rectangles, squares, circles, and other polygons. With the rectangles, the real similarity there is going to be that and your fraction strips. For example, you have a fraction strip that represents one whole, and you can see that 2 halves is exactly the same as one whole. So we'll be using these to help show and explain equivalent fractions. Here are some circles just to demonstrate one key concept here. You have 1/2 is equal to 4ths. Well, the first thing I do is look at these circles. They're the same size, so I'm good with equivalent. And then you want to shade in exactly half of it, which is 2/4. So in this case, 1/2 equals 2. Oops. 1/2 equals 2/4. Now, where you want to be careful though is down here. You have 1/2 here, and then you have a little shape over here broken into fourths. If I shade in 2 of them, these are not equal because the circles are not the same size. The whole has to be the same in order for them to be equivalent fractions. These holes are not the same on the bottom. On the top they are. 1/2 equals 2/4. Let's play around with some equivalent fractions here. I have some rectangle groups and then a polygon group, actually a hexagon. I'm going to show you some equivalent fractions. Say we take fourths and compare them to 1, 2, 3, 4, 5, 6, 7 eighths. We're going to figure out how many fourths equals how many eighths. Let's shade in 3 of these. 1, 2, 3. And since I kind of lined up these rectangles, beginning and end, their marks should be pretty much in sync. So 1, 2, 3, trace this down, 1, and shade all the way back. And you can see that 3/4 would be the same as 1, 2, 3, 4, 5, 6 eighths. You can actually look at another point here in that each individual fourth, if shaded down, takes up the same amount of space as 2 eighths. So you have 2 eighths and 1/4. Same with this one. 1/4, 2 eighths, and this third fourth, 1/4, 2 eighths. So 2, 4, 6, 6 eighths, 3/4. This fraction is halves, so we're just going to shade in one of them. And below it we have 1, 2, 3, 4, 5, 6. We have 6. So we're going to look at halves equaling 6. We have 1/2 shaded here. So kind of line these up. They're pretty well lined up. 1, 2, 3. And 1/2 equals 3/6. Down here, we're going to start here with this hexagon. 1, 2, 3, 4, 5, 6 again. And we have 1, 2, 3. We have thirds. What I'm going to do here is start out here and shade in one of them and note that there's nothing the same size I can shade in over here. If I just shaded in that same little part, I'd kind of be like that. But if I shade in 2 of these, now I kind of have that same little part here. And you have a whole third. So 1/3 over here is going to be the same as 2/6. And again, the key here is to draw shapes that are pretty much the same size as a whole, and then shade in the exact same amount in each shape. However, in this case you have 2 parts of the 6 shaded in, and in this case you only have 1 of the 3, but they're actually equivalent fractions because it's the same amount of space covered. I can use models to show and explain equivalent fractions. You have 2 problems here to work out. The first one has 1/4 shown here, and then it has eighths down here. 1/4 equals how many eighths? Just want you to kind of look at this, how many eighths are equivalent. And finally, I want you to draw a model to show 1/2 equals 4/8. So you'll draw eighths and a half, kind of put them on top of each other if you use rectangles, and show me that 1/2 equals 4/8 by shading in parts of the shape.